Why chemistry's momentum is hard to stop. It doesn't surge forward suddenly. It builds quietly. One reaction repeated often enough gains momentum that no single decision can easily slow down. The accumulation is so gradual that by the time anyone recognizes it as momentum, the force behind it has already grown beyond what any single intervention can redirect. At first, chemistry feels responsive. Adjust the conditions and outcomes change. Refine the process and performance improves. Control appears possible because the system is still small, still flexible, still listening. In those early stages, the relationship between intention and result is direct. Every input produces a proportional output, and that proportionality creates the impression that the system will always be this cooperative. To understand why this matters today, we need to look at how momentum forms in chemical systems. Every successful reaction encourages repetition. Repetition invites scale. Scale attracts investment, infrastructure, and dependency. Before long, chemistry is no longer responding to choice. Choice is responding to chemistry. The inversion happens without a visible turning point. There is no moment where control is formally surrendered. It simply becomes apparent, in hindsight, that the system started moving on its own terms long before anyone stopped to notice. In the early stages, momentum feels like progress. Systems grow smoother, outputs stabilize, predictability increases. Each cycle reinforces confidence that the chosen path is correct. The feeling of forward motion is indistinguishable from the feeling of being right, and that conflation is what makes momentum so resistant to scrutiny. Progress and momentum look identical from the inside. The difference only becomes visible when someone tries to change direction. But momentum has a hidden property. Once enough mass is moving in one direction, changing course requires more than intention. It requires energy, disruption, and willingness to absorb short-term loss. Chemistry does not resist change emotionally, it resists it structurally. The resistance is not hostility, it is physics applied to systems. The accumulated weight of infrastructure, expertise, supply chains, and expectations all moving in unison, all requiring force to redirect. This is where the story begins. With chemistry no longer accelerating because it is chosen, but because it is already moving. A system carried forward by its own success, gathering momentum that becomes harder to question with every reaction repeated. As momentum builds, chemistry begins shaping what feels realistic. Early on, adjustments are easy. Small tweaks produce visible change, but as systems scale, flexibility disappears. Reactions are no longer isolated events. They are parts of a moving structure. Altering one element means altering everything connected to it, and the connections multiply with every cycle of growth. This is where early tension emerges. Decisions that once took hours now take years. Changing a reaction means retraining people, redesigning equipment, rewriting standards. Chemistry has grown roots. Those roots extend into every layer of the system: economic, educational, regulatory, cultural. And each layer must be uprooted individually before the path can change. The depth of integration that once made the system efficient now makes it immovable. Momentum disguises itself as stability. Everything works, so nothing feels urgent. The system continues forward, not because it is optimal, but because stopping feels disruptive. Chemistry does not argue for itself. Its success argues for it. The argument is not rhetorical, it is structural. Every functioning process, every met target, every quarter of reliable output speaks on behalf of the status quo without anyone needing to make the case explicitly. Scientists observing these systems notice a pattern. The cost of change rises faster than the cost of continuation. Even when better reactions exist, adopting them feels impractical. Momentum tilts every calculation. The comparison between the existing path and any alternative is never fair because the existing path carries decades of accumulated investment, while the alternative carries only potential. Potential, no matter how promising, cannot compete with momentum on a spreadsheet. This creates a feedback loop. The more chemistry is used, the harder it becomes to imagine alternatives. Each successful cycle adds weight. Each investment deepens commitment. Chemistry becomes less a choice and more a trajectory. The feedback loop is self-reinforcing and self-concealing. It strengthens with every repetition while simultaneously making repetition feel more natural and less like a decision. What makes this dangerous is subtlety. No single decision locks the system in place. Momentum forms from many reasonable choices made consecutively. By the time limits are felt, chemistry is already carrying everything forward. The lock-in is distributed across so many small, rational decisions that no individual decision bears responsibility, and the collective effect is something no one chose but everyone contributed to. The system is still moving smoothly, but it is no longer easy to steer. The conflict intensifies when momentum collides with changing reality. Conditions shift, constraints tighten, new priorities emerge, but the chemical system keeps moving as if nothing has changed. The mismatch between the system's trajectory and the world's demands grows more pronounced, yet the system's internal metrics continue to register success because they were designed to measure performance along the existing path, not alignment with the evolving landscape. What once felt efficient now feels misaligned. Reactions optimized for an earlier world struggle under new demands. Side effects grow. Trade-offs sharpen. Chemistry is still working, but it is working for yesterday's assumptions. The system produces what it was designed to produce, and the problem is that what it was designed to produce is no longer what is needed. This buildup carries emotional weight because the problem is no longer ignorance. It is awareness without leverage. Experts see the mismatch clearly, yet altering course feels overwhelming. Momentum has outpaced intention. The knowledge of what needs to change exists, but the capacity to act on that knowledge has been consumed by the very momentum that created the problem. Attempts to intervene expose how deeply chemistry is embedded. Slowing the system threatens livelihoods. Redirecting it disrupts supply chains. The cost of correction appears higher than the cost of drift, at least in the short term. The short term is where decisions are made, and in the short term, momentum always wins. The long-term consequences of inaction are real but distant, while the short-term consequences of action are immediate and visceral. This is the emotional peak. The realization that momentum has become a form of control, not imposed by authority but by accumulation. Chemistry is not refusing to change. It is demanding a price for change that few are ready to pay. The price is not arbitrary. It is the honest cost of redirecting everything that has been built, trained, invested, and assumed around a single trajectory. That cost was always accumulating. It was simply never presented as a bill until someone tried to change direction. The system continues forward, not because it is right, but because stopping feels impossible. Chemistry has become heavy with history, carrying past decisions into a future they were never designed for. The climax arrives with a clear and unsettling truth. Chemistry's momentum is powerful because it is built from success. Every reaction that worked added weight. Every system built around it added mass. Momentum did not come from stubbornness, but from trust accumulated over time. Chemistry earned its forward motion honestly. That is what makes it so difficult to challenge. The momentum is not the product of error or negligence. It is the product of doing the right thing, repeatedly, until the right thing became the only thing. This realization reframes the challenge. Stopping momentum is not about blame or reversal. It is about timing. The earlier a path is questioned, the less force is required to redirect it. The longer it runs unquestioned, the harder it becomes to steer. The window for affordable redirection exists early, when the system is light and flexible. Once that window closes, only crisis or extraordinary effort can reopen it. The resolution lies in designing chemistry with intentional pause, built-in moments for reassessment, parallel pathways kept alive even when one dominates. Progress measured not just by speed, but by steerability. The discipline of maintaining options is the discipline of preserving freedom, and it must be practiced before momentum makes it impossible. This story is not about resisting chemistry, it is about respecting its inertia. Momentum will always form where reactions succeed. The responsibility lies in noticing when movement replaces choice. Chemistry's momentum is hard to stop because it feels like progress. But progress without direction is just motion, and motion once heavy enough carries us whether we agree with the destination or not. Understanding this gives us a rare advantage: awareness before inevitability, the chance to ask harder questions while change is still possible. Subscribe to join the journey. Why